In my previous lesson, I have done the ray diagrams with concave mirror. Now, I am doing the ray diagram with convex mirror. So, in my previous videos, I have explained how to draw the mirrors, how to draw a mirror ray diagram, and I completed concave mirror ray diagrams. Now, I am going to do convex mirror ray diagram. Okay. So, rules. What rules you have to make diagrams? First rule is a ray of light which is parallel to the principal axis of a convex mirror. Okay, these are the rules for the convex mirror, not concave mirror. So, concave mirror also have given the rules like this. So, now I am talking about the convex mirror. So, a ray of light which is parallel to the principal axis of the convex mirror appears to diverge from the focus after reflection of the mirror. So now this is how you have to draw a diagram. First you should draw a principal axis and then you draw a mirror using the protractor and take 2 centimeters F and take 2 centimeters C. This is the 2, this is only with respect to the protractor, compass protractor. Okay. Yeah, this ray, this convex mirror, if you draw perfectly using the compass, even that is also will do. So compass you should fix up the radius, 4 centimeters radius. From C you take 4 centimeters and radius and draw a curve like this. Okay, and mark a point in the middle F 2 centimeters radius. So you will be getting F and you will be getting C and you will be getting pole also. Draw a line through C and F. It will pass through the concave mirror, convex mirror at P. So shade on the other side. Okay, here one common rule is object should be always on the left side. As the principal axis is always a number line, so P is the 0. P is 0 and left side of P always negative, right side of the P always positive. So here the focal length is negative. Okay, focal length is the distance between F and P. So here object we are going to keep it back side, so that what happened, object distance will be negative. So here a raw AB is an object in front of the mirror. So from A you have to draw a parallel line. Let me draw a parallel line, and then what happened is it will reflect. How it will reflect? It appears to be reflecting from the focus. Okay, so this dotted line is only appears, it's not a line, because other side you cannot do. This side is behind the mirror, so you cannot, but this ray appears to be diverging from F. So this is any parallel. Whenever you draw a parallel line, you should keep and insert a point of incidence and focus and draw a line like this. So this is first rule. So second rule is a ray directed in the direction of the center of curvature of convex mirror reflected back in the along with the same path. So here this is directing towards the center of curvature. Okay, see, this is the directing towards the center of curvature. It comes back, same path में आ जाएंगे. Okay, so then rule number 3, a ray which is directed towards the principal focus of the mirror and becomes parallel to the principal axis after reflection. So again draw AB and you put a scale from this top to this focus. So then what happened? It's given wrong focus. Okay, it should be focus. It will go parallel to the principal axis. Rule number 4, a ray of light which is incident at the pole of convex mirror, right? So then what happens? Say again AB, and it is incidenting on P, then what happens? Angle of incidence, it will go angle of reflection. Angle of incidence is equal to angle of reflection. This is how these four rules will appear. Now let us see object at infinity of a convex mirror. So draw a principal axis, draw C, draw O, draw P, draw convex mirror, and an object at infinity. Okay, so then how this image is formed? From the infinity, all the lines parallelly they will come and fall on this convex mirror. So any as the rule number 1, any line which is parallel to principal axis, they diverge, they reflects through the focus. Okay, they appears to be diverged from the focus. So they appears to be diverged from the focus. So then what happened? Where is the image? Image is at F. Okay, the image is at F, focus, principal focus, right? So then what is the nature of the image? Because it is behind the mirror, it is virtual. You cannot catch it on the screen. Therefore, the nature of the image is a virtual image. It formed behind the mirror, and it is erect, and it is highly diminished. So it is behind the mirror, it is not written. You can write behind the mirror also. So virtual, erect, and highly diminished, smallest image. Okay. So this is the first case, object at infinity of the convex mirror. So then between infinity and the P, between infinity of the P. So again draw little bit closer to P. So then what happens? So parallel line, it goes through the focus, center of curvature goes in the same direction. So then these two lines are meeting at this point, A dash and B dash. Okay, so this is the image is formed. So in this case also image is formed behind the mirror. This is in front of the mirror, and this is behind the mirror. So behind the mirror means this image is always a virtual. You cannot catch it on the screen. You can only see, therefore it is behind. It is AB and it is erected image, and the size is smaller. So let us see what is written. Position of the image is at F, between P and F. Okay. So then wrong. This one is wrong. Nature of the image is virtual, and B is erect, and it is diminished. Okay, smaller than the original image. So these are the convex mirror. Only two ray diagrams are there. That's why ray diagrams of convex is not as important as this. So this mirror usually it will be displayed in the malls, okay, shops, etc. But in India you will be seeing very rarely. But in cities you will be finding these mirrors. Okay. Why convex mirror is used as a rear view mirror? For every class, for every vehicle, this rear view mirror, पीछे का जो भी देखना है, they will be using a rear view mirror. This is a convex mirror. Why it is used? Because convex mirror, it will be like this. What happened? It will cover wide, very wide field of view. Okay, the image formed in the convex mirror diminished due to the which convex mirror is gives a wide, not wild, wide field of view. Plane mirror is very narrow. You can't get a very wide field of view. So that's why plane mirrors usually they don't use. Convex mirrors are only used. This is an important examination question. Okay. So plane mirror will be there only inside. Why convex mirror is used? A question for you. No matter how far you stand from the mirror, your image appears erect. Then the mirror may be four options are given: a plane, concave mirror, convex mirror, or either plane or convex. Okay, so it is either plane or convex mirror. Plane mirror. Plane mirror always produces an erect image independent of the distance where the object is placed. Object distance wherever the object is placed at focus. There is no focus figure because it's completely plane. Focus will be focus and center of curvature will be there only curvature. So as it is a plane surface, there is no focus for the plane mirror. There is no center of curvature from plane mirror. Wherever you stand, the image is always erect. Okay. Name a mirror that can give an erect and enlarged image of an object. Answer: a concave mirror gives an erect and enlarged image when the object is between pole and the principal axis. Okay, but today I think this is okay. Tomorrow we will see few more concepts. So let me take you few more things. Let us understand the differences between um, convex mirror and concave mirror. Okay. Okay. So differences between concave and convex mirror. Concave mirror, convex mirror. First difference, it is made by silvering the outer surface of the part of the hollow sphere. So the reflection takes. Convex mirror is, it is made by silvering the inner surface at hollow sphere so that reflection takes place from the bulging surface. Okay. And second, it converges the light rays incident on after reflection. It converges. So it diverges the light rays when the rays incident on the mirror after reflection. That is why concave mirror is known as a converging mirror, and convex mirror is a diverging mirror also. So image formed by it is real as well as virtual. In concave mirror, in some cases the image is real, and in some cases the image is virtual. In convex mirror, it is always virtual for all the positions of the object in front of it. So wherever you keep the object in front of the convex mirror, the image formed is always virtual. So that means image is always formed behind the mirror. So these are the differences between uh, convex mirror and concave mirror. So now let us have the differences between plane mirror, concave mirror and convex mirror. So if the image is upright of the same size, it does not change in the size moving the mirror towards away. And then which type of mirror is this? Plane mirror. The image is upright, magnified and increase in the size on the moving the mirror away. Then which type of the mirror is? Concave mirror. Case 3. The image is upright, diminished, decrease in size on moving the mirror away. Then which type of mirror is this? The mirror is convex. Okay. So sign conventions, Cartesian sign conventions is also very important. How these signs are to be put up. So it is given by Sir Descartes. Is a Cartesian plane. We will be using in the graph sheet in maths also. This is a graph sheet, and this is also known as a Cartesian plane because Cartesian invented this. So in this there are horizontal lines and vertical lines. Okay, and they are placed at equal distances. So a vertical line will be there, y-axis, and a horizontal line will be there, x-axis, because it's not given, x-axis is not given, horizontal line is x-axis. Okay, so when right side of the y-axis is always positive, left side of the y-axis is always a negative, and above the x-axis is always positive, and below the x-axis is always negative. So these are the sign conventions. Now for example, this is the concave mirror. So when the concave mirror is there, so what happened, it's behind the mirror f2 and f2, and in front of the mirror f1 and 2f1. So the focal length of the concave mirror is always negative because it is in the left side of the zero, left side of P. So the focal length is always negative. Okay. The object distance is also negative here. This is object. Object distance is between object and the mirror. So this object distance is also negative. Okay. So the object should be always left side of the mirror, whether it is concave or convex. Object should be always left side of the mirror. Image. All distances appear parallel to principal axis are measured from the optical center. Optical center is P. All the distances should be measured from P only. Okay. Even if it is a downwards arrow mark image or upward arrow mark with y-axis, downward arrow mark with also y-axis. If the downward arrow mark, that means image is below the x-axis, then the height of the size of the image is negative because it will be negative. So the distances of right of the origin positive, left of origin is negative. Okay, and images measured perpendicular above x-axis are positive. X-axis is nothing but principal axis. and below are always negative. Okay, these are the points you should always remember. Always remember. Focal length of concave mirror is always negative because it lies on the left side. See, this is the concave mirror P, left side is there. This is the focus, and focus, the focal length is the distance between focus and the pole. Therefore, the focal length is always negative. And the focal length of convex mirror is always positive. Say this is the convex mirror, negative. Okay. So mirror formula, V is always image distance, U is object distance, F is a focal length. So 1 by V plus 1 by U is equal to 1 by F. This is the mirror formula. This UVF signs should be taken as per the Cartesian plane. Okay. So magnification also formula is there. Magnification is equal to size of the image by size of the object. You should always remember the formulas. H2 by H1. Okay. So because always object is always kept on the next object is always on the left side of the mirror, therefore object distance. Okay.